So I thought I'd just give you like a lowdown, hardcore plate tectonics kind of overview of the three types of plate boundaries, and then we'll just go over line by line the evidence. And you can do two things with it. First of all, you can watch it this week and make sure that you understand it when you do your assignment. And then the other thing that you could do is you could use this for an excellent study guide. Okay, so let us view the show. Okay. So this is Earth's surface, if you've seen lots of times, and we've been talking about plate tectonics now for a few weeks, and you can see here all the plates. So if you remember last time I saw you guys, we talked about continental margins, and we talked about an active continental margin, which is near the edge of a plate. And it's active because there's earthquakes and volcanoes, and it's called the Pacific type continental margin because look, around the Pacific you've got lots of active continental margins. So the edge of the continent is right at the edge of the plate. It's narrow, there's a steep drop off, and we compared that to passive continental margins. You can see here's the edge of the continent that's submerged underwater. So you're in the continent, you're over the continent, but you're still in the water. Like here also, yeah. And we talked about how these are passive or Atlantic type because most of them are in the Atlantic, yeah. And they're passive because they're far away from the edge of the plate. So here's the continental margin, here's the plate boundary, here's the continental margin, here's the plate boundary. So you're far away from the edge of the plate, which means there's no earthquakes, no volcanoes. That's why they're called passive, because there's very little action going on there. And these continental margins are broader and shallower, very gradual drop off. Okay, so we talked about that. And you know where the plates are: South American plate, Nazca plate, North American plate, Pacific plate, Eurasian plate, African plate. So you know some of the names of the plate, Antarctic plates. And we're just going to today go over specifically the three types of plate boundaries first, and then we're going to go over the evidence. So first we talked about divergent plate boundaries, and I just want to kind of reiterate, we're going to go over what happens at each. You should be able to draw a cartoon. You could draw this cartoon or something simpler, but something similar to this, and give us some examples. So here's a divergent plate boundary. So what happens at a divergent plate boundary is two plates move apart from each other. It's also called a spreading center. So a divergent plate boundary, it's also called a spreading center because two plates are spreading apart from each other. And this is where new seafloor forms, right in the middle there, where new seafloor. So this is brand new baby seafloor forming right here in the middle, and where the two plates are pushed apart. And this is also where the youngest seafloor is. And if you took the Alvin submarine down here, or a different kind of camera system, and you went right in the middle here in this fissure, this is where you would see those hydrothermal vents, the undersea hot springs coming up, right in here. Okay, and some examples of divergent boundaries are the Mid-Atlantic Ridge, the East Pacific Rise, East African Rift Valley, the Red Sea. So those are all divergent boundaries that we've discussed in class, where two plates move apart, new seafloor is formed, seafloor spreading, and you get mild or shallow earthquakes in this area. Okay? So here's your example of the Mid-Atlantic Ridge, where you get this Rift Valley. Yes, here's your continental shelves, your passive continental shelves, and two plates moving apart. Okay, and you see, we talked about also last time, the sediment gets thicker the further you are away from the spreading center. Okay, and then as I mentioned, if you took Alvin down in the middle of the rift, you would find that there would be these black smokers, or these undersea hot springs, hydrothermal vents, right in the middle where the new seafloor is forming. Okay, and here you have what the Atlantic must have looked like about 50 million years ago, and it's still spreading today. And here's where the East Pacific rise was about 50 million years ago. And you see the North American plate and South American plate have been moving this way for the last 50 million years. And you can see India moving this way for the last 50 million years. Okay, here's your Mid-Atlantic ridge, your East Pacific rise, your East African Rift Zone, your Red Sea. All these areas are spreading centers where the sea floor is moving apart. Two plates moving in opposite directions. Sea floor spreading, okay? Baby new ocean being formed here. The youngest sea floor is here. And these are like an undersea mountain chain. Okay, all undersea mountains. Okay? So now we're going to talk about the three types of convergent plate boundaries. And this is just your basic one where you've got your oceanic lithosphere, which is made of basalt, crashing into your continental lithosphere, which is made of granite. And because the basalt is more dense than the granite, the oceanic lithosphere subducts underneath the continental lithosphere. So one plate is subducting under the other when they converge or crash together. And there's a subduction zone. This area is a subduction zone. And here you get a trench where subduction happens and volcanically active mountains, right? And you also get deep earthquakes here, much deeper than in a spreading center. So this is a convergent plate boundary. What happens at a convergent plate boundary? Two plates come together. The denser plate subducts underneath the less dense plate, and you get big earthquakes, big volcanoes, and a volcanic mountain chain. Okay? So that happens on every situation. And this example is when oceanic lithosphere crashes in or converges with continental lithosphere. Some example like this would be the Andes Mountains would be here, and this would be the Peru-Chile Trench where the Nazca Plate is subducting under the South American Plate, and that's something we've talked about a lot in class. Okay, so here's your cartoon, ocean, continent. We're going to talk about the three types of convergent plate boundaries. We talked a little bit about it just then. You get an ocean and a continent converging together where the oceanic crust subducts underneath the continental crust. You get a trench right next to this volcanic mountain range or volcanic arc. Okay, so as the one plate is subducting under the other, part of it melts and it comes back up as volcanically active mountains. Okay, right next to a trench. We talked about the Peru-Chile Trench and the Andes Mountains being a really good example that we've talked about all semester long. You also have, in addition to ocean-continent colliding, you have ocean and ocean colliding when two plates that are oceanic come together. So you get the older oceanic lithosphere subducting under the younger oceanic lithosphere. Okay, so two oceanic plates come together. The older, more dense one subducts under the younger, less dense one. And instead of getting an arc of mountains, you get an arc of islands. And just like the mountains that are all volcanically active, the islands are all volcanically active. And it's for the same reason that one plate is subducting under the other, and the plate that's subducting partially melts and then breaks through the lithospheric plate in the form of active volcanoes. Okay, so an example of this that we've discussed a few of them: the islands of Japan, the islands of Indonesia, the islands of the Aleutians are all really good examples of two oceanic plates coming together. You get a trench on one side, then comes the island arc that are all volcanically active, and then a shallower sea on this side. And normally it's when two oceanic plates come together, the older, more heavier, more dense lithosphere subducts under the shallower, less dense one. We had those examples here would be the Pacific Plate subducting under the Japan Sea, which is shallower, or the Arctic Ocean, which is shallower in the case of the Aleutians, or here's would be the Java Trench, and this would be the Java Sea, shallower sea. Okay, and then the third thing that can happen is if you have two continents coming together. And what happens here is that as one plate subducts under the other, and you see there's not volcanic activity, right? But you get what happens is the continental crust smashes into each other and uplifts, causing huge mountain ranges. And the place on the Earth where this is happening, of course, is where the continent of India is converging. There's a convergent plate boundary of the continent with India, the continent of India converging with Eurasia, and you get the Himalaya mountains growing, and they still are continuing to grow because India is still colliding with the continent of Asia. And as they continue to collide, the Himalayan mountains are continuing to grow. And as I mentioned, there's a little metal plate on the top of the Himalayas that registers its the height to satellites, and so satellites are measuring how much the Himalayas are still growing today, just centimeters per year.